Bioinformatics.
Okay, welcome to the lecture on Unix Shell Part 2. So today I'm going to go over some things that don't feel like genomics, but should just expose you to some more ideas about all the different things that are potentially possible within a shell environment. So I would recommend that you log into your AWS server and take a minute to pause and follow along at different parts throughout this lecture. So what I want to talk about today is how can you finally take that leap from code making things more difficult to making code work for you and starting to make things a little bit easier as you scale things. And so that involves talking a little bit again about scripts, variables, and then diving into something totally new to you, which are loops, if then else statements, and then the use of pseudocode to kind of hopefully make this make a little more sense. So we've talked about this a little bit early on. A script is really a set of pre-written commands, things that you could normally execute often at the terminal itself, but it's things that you want to automate or do a whole set of things in a row at once. And so you can write a lot of commands line by line and then execute them all at once by executing the script file. So to kind of illustrate that, imagine you were to type echo hello world. And so again, by convention, the command prompt is this $sign here, so we know that this is what's being executed. You're not executing the actual $sign though. And then beneath that is the output. So echoing and typing hello world will have hello world print to your terminal. Now, we could make this a script where we could make a text file using Nano, something like that. And I'm going to designate those throughout the lecture as the contents of this script as a standalone text file will be within this kind of box. And so at the very top of it, you're going to have this funny looking thing, but then you could also put command lines beneath that. So echo hello world. This first line up here is called the shebang. This is basically not going to be executed itself, but it tells the computer where to look for how to run your script. So in this case, this is a bash language. And so it's telling the computer where that bash language is actually located. If you wanted to execute a script in Python or R or something else, you could alter this shebang line. For the purposes of this class, everything we do is going to have this standard shebang line at top though. Another thing to note is you can annotate your script, and we've shown this several times throughout the labs. Anything you put a number sign or a hashtag, or we call it a comment, in front of it is ignored. So you could put this, you can make notes like this throughout your script to indicate things to the reader that might be using it later or even to yourself in the future without impacting how it is actually run. So if you take a second and go and actually write this, and I'll do that same thing. If we were to nano, we'll just use nano here, nano, and we'll make a script.sh is what maybe we'll call it. And so we'll start with that shebang line, bin/bash. And then here we could say echo hello world. And we can hit Control X, hit Y for save, and hit enter. Now, if we were to try and // and run this script.sh, one, it's not going to let us tab complete because it doesn't think it's executable. But if you were to even force it to run, it's going to say permission denied. So whenever we make a new script, by default, they are not executable. We always have to do that chmod +X to the file, and now we can execute it. And so here's just the output of executing that script, which is what we would expect. Okay, so now that I've kind of defined again for you kind of the basics of how a script works, let's talk about the next important piece, because why write a script if you can't use it on multiple things? And this is where the concept of variables comes back. Variables are basically a temporary place to store information, and you can set them to be equal to anything you want. It could be a number, it could be a file's location, it could be the contents of a file. And so you can then use it as a placeholder for all sorts of fun things. And so as an example, let's use a number first. We could set the value of life equal to 42. Now, if we wanted to double check that that actually worked, we could echo it, right? So if we echoed, and the convention in shell is that you put a $ in front of variable names so that it knows it's a variable. If you put echo life, it would just echo the word life. If you put a $ in front of it, it goes, oh, you mean the variable life. And so here the output would be 42 because we already defined the variable life as being equal to 42. Okay, and so you could expand your script that you just started practicing with, where now within you could run 2 commands. You could set the value of life to 42 and then echo life. I'm not going to do that because I think you can probably see how that works. If you were to execute this script, what the output would be 42 because life is set to 42, then we echo life and life is equal to 42. So not super helpful yet, right? But we're just getting the basics. So where this becomes helpful is when you start to use variables that you input as you run the script. And so by default in Bash, if you execute a script and then you put words or anything else after it, in order, it automatically assigns them to variable 1, variable 2, variable 3. And so what I'm executing here, where I'm saying .blah.sh 1, 2, 3, is exactly the same as if inside the script I had said set variable 1 equal to 1, 2 equal to 2, 3 equal to 3. This is where it starts to get more powerful. So if I wrote a script that had a shebang line and said echo variable 3, 1, 2, and then I executed it by saying ./blah.sh love shell I, what output do you expect? So let's try that. I'll just edit the existing one. And so we'll say echo 3, 2, and 1, and save that. And if we were to / our script and say love shell I, and I think I got the order right, I love shell. Okay, so it went and reordered them based on how I use those variables in the script. Although I don't find much use for this, I'm sure you guys could probably think of something creative. You could even have your script prompt the user to input a variable. So if you say read var name inside of your script, it will pop back a prompt to ask for a input for what the variable will be equal to. And then here you could use it. So here we're saying, hello, who is this? The user will write in who it is. And then echo, it's nice to meet you, insert variable name. I'll demo that here in a second, but I also want to point out commas and quotes and all sorts of things have uses beyond just what they look like. And so certain characters have special functionality, and quotes in particular do. And so here, if you're going to use a quote here, or a single, whatever it's called, you have to use a backspace to explicitly tell Bash to treat it as that character rather than a special character. I encourage you to try it without that backslash and see what happens. That's how we learn, by playing around. Okay, so let me add in this read var name. So we'll go back and we will nano our script. And let's say read var name, and maybe we'll prompt the user too by saying echo who is this question mark, and then we will echo hi there var name, and we'll go ahead and execute this. Who is this? This is Clayton. Hi there, Clayton. And now I feel special. This is all focused on shell, but before I go any further, I just want to mention that learning one language makes others easier to learn, because even though they handle syntax differently, the types of commands may vary, the underlying principles of what you're doing and why you're doing it and how you're doing it are really universal. And so once you get the grasp of some of the things like how to use variables, how to use them in scripts, and then loops and things that I'm going to be talking about next, are really will transcend to all the different languages that you may or may not need to use in the future. So, if-then statements are a really bread and butter part of automation, and one of the things that I use the most. An if-then statement basically is like asking a true or false question and then sending you down one path for the rest of the script if it's true, and the other path if it's false. And so if true, we go down this little side branch and maybe run some commands, and then eventually come back to where the false path skipped ahead. So these are maybe operations that should only be done if certain criteria are met. And the if condition is asking if you have those criteria. So I will mention as we go forward that Bash, particularly as it relates to this kind of stuff, is a lot more finicky than something like Python or R. It gets really picky about spaces and things, so always double check if you're following along your spacing and your usage of quotes and things like that. So the basic format for this if-then statement in the format for Bash is that you start with if and then some condition within brackets. And again, spaces matter. What you want the true path to follow is housed in between a then and then a backwards if, or it could stand for finish, okay? I kind of remember it of being a backwards if because it's kind of like an if then, and this is if it's true, it goes in there. So here, what we're asking is if this variable, again, variable 1, we can input that as we execute the script, -gt greater than 100. So if this variable is greater than 100, it's going to pass as true, which will put it down this then pathway. And it'll echo large number. And then just for fun, print the working directory that you're in. And then it will end, no matter what your number is, since it's outside the if statement, it will print the date. So if your number is less than 100, you'll just see the date printed. If it's greater than 100, you'll see large number, present working directory, and the date. Okay? I'm going to go type this in and show you this. I want to mention that although it's really a fantastic idea to always indent within your different then and if statements, because it really clearly shows that this is kind of housed within kind of a subset of the path. A lot of languages like Python require this formatting. Bash does not, but your script will get very messy if you don't do that. And so what we're going to do is we're just going to make this if space bracket space our variable 1, which is one that we pass in, is greater than 100 space bracket, then enter, tab it over to make it easy to track, large number, exclamation mark. Maybe we'll also get the present working directory. Then we will end it, and then we'll pass the date no matter what. And so if we close this and go ahead and execute our script, and we say, now let's think about what this is going to do. If I say 101, we should see everything. Look, there we go. It said large number, present working directory, and the date. What if I said 10? We're just going to get the date. Okay? So this is just a really simple example with a few commands to show you how this works. Building on that, you don't have to have the false from the if-then go right to the end of where the then statement ended. Like you don't have to have jump from, okay, it's false. You have to meet up with the if statement for true after it's done. You can have your own divergent path of extra commands for if something's false. And that's designated with the term else. So basically the terminology is if the condition is true, then you go this way. If the condition is false, else you go that way. So if it's true that way, else you go this way. And that's really kind of the basic function of this. And this allows you to, you can nest these, you can have if statements within your else statement to kind of have this branch fork pattern to do all sorts of crazy things. So here's what an if then else statement would look like. So here we're doing the same thing. If our variable is greater than 100, we'll echo large number, present working directory. If it's not, we will echo terrible. Then we will finish our if-then statement, and everything will do the date. Okay? So let's give this a shot. So we will nano our script, And all we're going to do is add an else statement here. Else echo terrible. We'll add a little ellipse at the end. And if we save that, and now we do 10, terrible, plus the date. If we did 101 or 1,000, large number, then present working directory, then the date. Okay, and so to further nest beyond that, you start to use else if. And so else if lets you nest within more of these if statements. So here you can see it's if some condition, then do some commands. Either before or after those commands, you could say else if. So basically you're asking for a second condition that you're only asking of things that were true of this original if condition. Then do something else. Else do that. And so you can start to kind of branch these further and further out. Okay, so here's an example of an else if statement usage if we're thinking about how to deal with grades. So again, beginning here's the same. If your variable is greater than, in this case we use an E for equal to, so greater than or equal to 90, then you echo, you get an A. Now, because we already have all the things 90 or higher that have gone down this first if path, we can then have an else path that also has an if condition attached to it. So here we fork once and things that are 90 or greater follow down this path where they echo, you get an A. Everything lower than 90 will filter down and now be asked another condition question. So else if your variable is greater than or equal to 80, then you echo a B. Else, basically if you were false to both of these in a row, both levels, then you would echo, you get a C or lower. Something to kind of further make these useful, but also add another layer of complication, are Boolean operators. That is a really fancy word for things that you use all the time and understand in day-to-day life. The main Boolean operators are the words and, or not. And in Bash, they're signified by two and signs, two pipes, or an exclamation. And so how does this work? Well, if you put it at the beginning of your condition, it's basically opposite day. So if 1 is greater than or equal to 100, but opposite. So if this normally would be true, when you put this exclamation in front of it, now it's saying anytime it's true, it's going to be false. And if it's false, it's going to be true. So here, if you put 90, it would pass this as true and go to the then statement. So 90, it would be then echo not a large number, present working directory, finish, okay? You could also have two conditions required to be met to pass down that then statement pathway. So using the and signs, you could say it has to be greater than 100, and your second variable also has to be greater than 100. So if we're passing two variables, both have to be greater than 100 to be able to echo both are large num. So let's try that one, okay? So let's go. We'll get rid of our else statement for now. We want to say both are large number. And so let's say 1 has to be that, and then we'll put the Boolean operator and do our same thing. We're going to look for variable 2 also being greater than 100. And so if we save this and we execute our script and say 101 and 150, this should say both are large number. And it does right there. Now if we did 15, it's just going to go to the end because it didn't actually meet both conditions. You could also try this with the OR operator. So in this case, only one of them has to pass. And so you could echo at least 1 is a large number. Now I won't demo this one. You can go try this one. Replace those two and signs with the pipe and then execute it saying 1 is 50 and 1 is 150. And you should get it passing through that then pathway. So if you want to pause this and practice and test yourself, think about how might you write a statement that will tell you when either two numbers are larger than 50 or at least 1 is larger than 100. So either of those two possible scenarios. So you can go ahead and pause it and see what I do. Okay, so that was probably kind of tricky. There's several different ways to do it, but here's the way that I did it. We're going to start with an if condition, and within several brackets, that is going to be, the first condition is your variable is greater than 100, or variable 2 is greater than 100. So that's one of our two possible scenarios that we would be happy with. One of them is greater than 100. Or 1 is greater than 50 and 2 is greater than 50. So here we have kind of like this nested condition where we need one of these larger Boolean operator containing conditions to be true. So either of these situations would then echo big numbers are happening. You could also make it more specific if you wanted. Maybe you did it this way. You said if 1 is greater than 100 or 2 is greater than 100, then echo at least one number over 100. Else if, so if that's not the case, then check this condition, and that condition is 1 is greater than 50 and 2 is greater than 50, then echo both over 50. Else you could echo nope if both were like 20, something like that. Okay, so that's kind of the basics of if and conditions. Now let's talk about how to iterate through things multiple times. This is what we call loops. You can basically insert in a list of tasks a loop where when you get to a certain task, you can have some condition met that prompts it to start back over and go through it again. It could go for infinity, it could go X number of times, or it could go through your out of items to push through. And so the format for this is for some variable name in a range of something, do, and then a bunch of tasks. So as an example, for a variable in 1, 2, 3, 4, 5 to, this could be to infinity, do command A, command B, command Z, and then done. This could be not numbers, but it could be files. For some variable in file 1, file 2, file 3, do command A on this variable here. Command B, command Z, done. Could be for some output in something that you're executing here. It could be catting a FASTQ file, for example. Do command 1 on the output, or command 3 or 1 on the output, and to infinity. And so here's what that looks like in the most basic sense. For I, which is going to be the variable in this series of 1, 2, 3, 4, 5, do echo welcome variable I times done. Now, what this means is that this is going to go through for each one of these, this is going to go through this loop for each one of these individually. And at each one of these numbers, I is going to be set to being equal to that. So this is going to say welcome 1 time, welcome 2 time, welcome 3 time, welcome 4 time, and welcome 5 time. Rather than type it all the way up, it's very easy to put numbers in a range from 1 to infinity. You could say for number, and here number will be the variable instead of I. I like to use I typically because it's short, but this can also be descriptive. So for number in a series of 1 to 100, do echo number. Okay, I'm going to show you this one. Okay, so you could write these kind of loops right at the command interactively and execute them, but because they're kind of long multi-line commands, it's really easy to make errors. I really recommend putting them in Nano or writing them in Sublime and then uploading the actual script if it's complicated into your server. So I'll show you how to do this in Nano and then just execute it like we've been executing scripts. So for number in a series of 1 to 100, do echo number. Done. Okay, so now if we go ahead and chmod that, we should be able to execute our loop.sh, and it printed all the way number 1 to 100. Okay, so you could very easily change this from number to I and this to I. You could make this to 1,000, 1,000,000, whatever you want. So how do we combine these things now? Because what if I'm lazy and I want to automate grading in Bio 1 or Bio 113 or any of these other courses I teach? And I want to automatically assign an A to any student getting over a 90% in my gradebook. Now, I know that Excel could do this for me, but we're using this as an example because once we get this working, we could use this on data sets far larger than Excel could ever even open without crashing your computer. So before I just start typing code, it's always good to take a step back and write the pseudocode. Now, this is something I think is really important to develop as a skill. You just have to think about what you want to happen at different steps. And this is why I always talk about writing and talk about thinking about what's possible. That's why I expose you to all these different things, so you have a sense of what you can and can't do, not a memorization of how to do it. Because pseudocode is not about how to do something, it's about what you should do or need to do. And so if I were to write pseudocode, which is writing each step of my command in plain English, well, this is what I would really be trying to do. I want a script that will look at grades and say, if a student has over 90%, it's like a condition statement, give them an A. If not, but they have over 80%, give them a B. That kind of sounds like an if-else statement, right? Etc. Continue on down the grades. So now this is where learning how to Google code snippets comes in. Because if a student has over 90%, well, we kind of know how to do that. We know how to set up that condition, that if statement, and if we didn't, you could probably Google and find it. So we already know how to fill in code for that step of the pseudocode. It's if our variable 1, if we're passing it this way, is greater than or equal to 90, right? Then echo you get an A. That's exactly what we've already been doing. And so you can pass this down. We have kind of already revisited these things. So if not, but they have over 80%, well, that's the same as saying else if your variable is greater than or equal to 80, then you get a B for this last one, okay? And so we've already put together the code that you would need to adapt for this string of pseudocode. And here's what it looks like, just so I don't go back and type it all in right now. Bin bash, if your variable is greater than or equal to 90, then echo you get an A, all the way down to else if greater than or equal to 70, you get a C. If you don't even pass that third possible else if statement, then that means you were getting lower than a 70, and you get to retake the course. And so here you could execute this script and say .grade.sh, 85, you get a B is what it would return to you. Okay, so that's showing that our string of conditional statements are working. Now, the final problem is, how do I automate it though? That's just, I don't want to have to type in each grade by hand and have it tell me what to give them. I want to automatically assign it. So let's say I have a grade book, and it's got everyone's name, Billy, Abby, Joe, and Swarley, and they each have, in this case, the format is their grade is next to their name. Maybe it's the first two columns of a grade book. And so they're all getting a range of grades. And so this is where pseudocode comes in again. We use pseudocode to come up with the flow of our conditional statements and loops. And so I like to kind of show this one. This is just showing you what the pseudocode for making a hot beverage might look like. You might put a tea bag in a cup, you might boil water, and then it would ask you a conditional statement. Is the water boiled? No, it returns to the loop. Is the water boiled? No, it returns to the loop. Is the water boiled? Yes, pour water in cup. If they want sugar, then add a teaspoon. If, else if, do they want milk? Add milk. Else if, does it need a stir? Yes. Otherwise, else finish. Kind of something like that. And so this is actually not meant for shell, but this is just kind of illustrating how pseudocode works for kind of looking at a flowchart or a diagram of what you really want to do when things get more complicated. So here's the pseudocode for what I want to do for my grade book. We already have the script for figuring out the grade, so now we just need to apply that. And so to apply that, what we really want is to take this grade book, and for each line of the grade book, so we want to pull out each line separately, we want to split the name and grade into separate variables. We need to get that grade away from the name so that we can run it in our script, but then still keep the name to apply back later. And then we need to execute the script we just wrote and then end the loop effectively. We haven't learned how to do this. We don't know how to pull each line out of a text file one by one, right? So how do we? The nice thing about breaking this up into pseudocode is that if your entire assignment for a week in a class or even a day was find me some shell code that will let you go through a text file and pull out each line separately, you could figure it out even if you had never learned any shell before, because you could Google and you could find some message board where someone asked this already. And so this is where just being a little bit of a sleuth on the internet is really helpful. So take a second, pause this, and go see if you can figure it out. So here's what I found. I found someone said, hey, I'm trying to take this file that says hello world, and I want to have it print out each line separately. And so this person put down what their example was. They said, I've been trying this, where you say for I in catting your input variable, do echo that I variable. So this should look familiar here. The only difference that we didn't talk about is the output here that it's going to iterate through for the loop is each line of catting whatever file name you passed as variable 1 when you executed it. And so here it's doing all of them, but the problem is this person's posting an example that it's not doing what they want because it's splitting when there's more than one word on a line. Okay, so see, it's saying hello world, hello world. If we were to do that with our script, this is what it would look like. We don't want each one of these names and grades separate to go through our script because we'll lose the connection between Bill had the 86 and Abby had the 92. So we're close, but not quite there. If you scroll down the page a little bit further, Cunningham's law comes into play. And so Cunningham's law is this idea that the best way to get the right answer on the internet is to not ask a question, but to post the wrong information. And so the example that person posted as what they were trying to do made someone on the internet say, I got to show them that I am right. And lo and behold, you scroll down and someone put a better way of doing it. And it is catnames.txt. If that's the file name. For us, it would be gradebook. While read line, then do. So this is a totally different format for the beginning of the loop that we haven't even looked at yet. But I bet if you stop and think about it, I think we can figure out what it's doing. Catting names.txt, well, we know what that is. We've done that in labs many times. That's going to pipe everything down on separate lines, and then we're just piping it over to this command wow that we haven't even talked about, and it's reading each line, and then here they're echoing that line. So each line is now becoming the variable line, is my guess. And you could execute this just to see. So if you were to adapt this and say cat while read line, do echo line, and then you executed that loop.sh grades.txt, well, it's going to do exactly what we want. And this was just from skimming around, trying things out. This is really how it works. And so for this second part, we want to take each line now and split the name and grade into separate variables. So we've done this already too. We have used cut. You might not remember it, but we used it back when we did our human genome pattern exercise. Cut lets you pull things out in column format, right? Well, if you've just got a couple things on a line and they're separated by spaces, you can almost think of each word as a separate column separated by white space. And so if you didn't remember that, you could have also eventually stumbled on that from Googling as well. Here's an example here that someone has done that, where they're saying, well, you could set this variable ht is equal to whatever your variable name is, and then cut out the first column or the second column. And so that's what we could do here. So while we're reading that line, we could do this. We could say name equals, echo the line, and then cut out the first column when the separator is a space. Then set the variable grade as equal to echoing that line, again, same variable, and pipe it to cut out the second column separated by a space. And then to test it, we could say echo name has grade in the class. And if we were to execute that, it would say Bill has an 86 in the class. Abby has a 92 in the class. So we could just continue now by using that script that we wrote and then end the loop. Okay, so what does that whole thing look like? Okay, so we just pieced together this first part to get those variables within our loop, the name and the grade variables, basically off of that line variable. Now we can take that information and we can run it through the script that we put together. So now instead of $1, we're going to use that grade variable and say, if grade greater than or equal to 90, then echo name gets an A. Else if grade greater than or equal to 80, then echo, and you can fill it in. You could say name gets a B. Else name gets a C, or gets to retake the class, whatever you want. And so now if you execute this on grades.txt, it will work just like you want, and Swarley gets to retake the class. So we could go further on and have it actually save that into a grade book again, a new grade book, but I think you guys probably get the point. And this is, kind of as a silly example, but these concepts are used all the time. I use them all the time. There's a figure I put together for a paper where I wanted to look at overlap between a bunch of different p-values of different ways of normalizing RNA-seq data. And what I did was built a bunch of nested condition statements to bin the genes into different bins, and then I could represent them in a nice tri-Venn diagram. And so here is some of that code, and you can probably look at this and see a little bit about what I'm doing. This is in a totally different language though. This is in Python, but you can see there's Boolean operators at play here, and we've got some condition statements. There's a loop here for G in something, and then you've got your if statements. So, and then your else if is kind of if not, but this is, something that if you can get the hang of this, this is really powerful when it comes to manipulating data. And when you pair it with regular expressions, you can really do anything with character-based data that you can come up with.